So now we are going to work with the situation where the data is paired, or you can say that they are dependent. In that case, we can denote the difference of the two means, mu1 minus mu2, as mu d, right? Then you would say that the difference of the two means is greater than d naught. Okay, that is the specified value, or you can say hypothesized difference of means. So here in the right tail test, it would be that the difference of the two population means is greater than some quantity. If it is 0, it would mean that mu1 minus mu2 is greater than 0, or you could say mu1 is greater than mu2, right? So mu1 minus mu2 is mu d. Okay, we are using this notation mu suffix d because we are dealing with paired data, and if you can recall, we take the differences of the two set of observations and we denote it by di's, and then we take sample mean, so we denote it by d bar. So in order to just be in sync with what you're going to use notations so that you are going to use in these few lectures, that is why I've kept it mu d. If you want to keep it mu1 minus mu2, that is also fine. So obviously the test statistic in this case would be d bar minus d naught over sd by root n, right? This we know from your, let me just show you, this is coming from theorem 6 in week 5. Okay, so there also, if you can recall, we have d bar. So d bar is 1 over n summation di's, right? And what are di's? 1 over n summation di's are difference between xi and yi. So you will first take the difference and sum it over the n possible values, and then you will take divide by n, so you will get the average. And d naught is basically you are taking the difference of the two population means, right? mu1 minus mu2 under the null hypothesis, and you divide by this standard error and you get your test statistic. So in this case, you would be rejecting the null hypothesis if the test statistic that you have obtained is greater than T alpha, that is the critical value. Okay. Likewise, you will have the left tail test where the difference of the two means would be less than D naught in the alternative hypothesis. Okay. This would be your test statistic again, same test statistic. And the rejection region would change because now you would be working with the lower tail of observations, and you can look for this, you can look the same theorem that I just referred in the previous slide. Okay. Likewise, the two tail would be there, that the difference of the two population means is not equal to D naught. In this case, you will get D bar minus D naught over SD by root n. So it is same way, if you can recall, we have the x bar minus mu naught S by root n, right? We had this for a single sample problem. So what we do is we have paired data. We try to make it independent by taking the difference of their corresponding observations. So what you get is your D bar. So it is, you can consider that because this one is also for single sample only, right? So same way, instead of x bar, you are replacing that with D bar. Instead of mu naught, here we are using this difference. S is replaced by the corresponding sample standard deviation, and you're dividing by the root n. And you would reject it if it falls in the rejection region. If T star, that is the test statistic, is less than minus T alpha by 2, or if it is greater than T alpha by 2, you would be rejecting at those places. To understand this, let us consider this example. A study was initiated to determine the effectiveness of new exercise program designed for a group of 10 office workers. The program aimed to analyze its effect on reducing stress levels, with stress measured using a standardized scale before and after the program. The hypothesis is that the new exercise regimen leads to a decrease in average stress levels. So here you can see that here one thing is that it is paired, right? Because you are looking at 10 office workers and you are observing certain values on them before you are giving them this new exercise program, before they initiate that program, and after that. So the observations would be dependent. and the observed data that you have obtained before and after completing the exercise is given to you for the 10 participants. You have to assess this data in order to test the claim that the exercise program reduces the stress level of an office worker at level of significance 0.05. So how can we solve this? We immediately know that we are talking about paired data set. So the previous two results that we studied, right, that won't be applicable in this situation. Here we will be considering this as your xi's, these are your yi's, we can calculate di's, right. Once you have di's, you will calculate your d bar, you can calculate the standard deviation also and substitute in the formula. So let us see what is the question. So hypothesis, alternative hypothesis, it is a right tail test because you want to see that after the regimen, new exercise regimen is actually good, right. So it means that after stress levels, this one. So let me just show you. Test the claim that the exercise program reduces the average stress level of an office worker, right. So if you look at the average stress level, if you are denoting for the first one, if you are denoting by mu1, after it is mu2, it means the average stress level earlier was more than the second one, right. If you want to prove this one, right. So that is why we write that difference mu d, that would be your alternative, and this is going to be your test statistic because here d naught is 0 and you are going to reject the null at 9 degrees of freedom because it is n minus 1. Okay. So you will calculate these di's for each pair of observations. You can get this too. And substituting this value in the test statistic, we have that it is approximately 12.829. Okay. And the critical value that you get at degrees of freedom 9 is 1.833. It means that your test statistic that you have calculated is greater than your critical value, so you are going to reject it, okay, because T star is greater than equal to T alpha. Okay, so under this situation we reject the null hypothesis and we are going to accept the alternative that yes, you have significant statistical evidence to conclude that the exercise program effectively reduces stress levels among office workers. Okay, so this shows that the program is good. So these three were your test for difference of the two means. Next we move on to the test for the two variances. We know that we deal with the ratio of those variances. And if we are having two variances, ratio of two variance, first is that when we are dealing with variance, we come across chi-square distribution, and when we have two such variances, we will come across F distribution. Okay, because ratio of two chi-squares divided by their respective degrees of freedom gives you the F distribution. Okay, and its degrees of freedom are also aligned in that way, right? So the first one is your one tail test, or you can say it is your right tail test. So in right tail test, you will have this one. So here we are basically considering that the D naught or the sigma 1 over sigma 2, that is basically 1 over here, right? So sigma 1 square over sigma 2 square, this is greater than equal to some value, right? So maybe sigma naught square I can write, and that is 1 given to you. So here what we will use? The test statistic would be the ratio of the two sample variances. Again, we have seen this result also initially when we studied week 5, and in this case we would be working with 2 degrees of freedom, and you would be rejecting the null hypothesis if this value, that is a test statistic, is greater than this. Or if you use this asterisk over here, then you can easily see that F star is greater than equal to the critical value that we have. Okay, so in that case you would reject the null hypothesis. Same way, case 2 would be your left tail test. So in left tail, it would be, the alternative would be defined in this way, and the test statistic would be the ratio of the two sample variances. Again, same thing, and you would be rejecting the null hypothesis if your F statistic that you have obtained is less than F of 1 minus alpha. So it is calculated at 1 minus alpha, right? So it is something like this. So here in the previous one you would have F alpha over here, and if you are considering this situation, so it is somewhere here F 1 minus alpha. So this is your alpha and this is 1 minus alpha. Okay. So you are going to reject the null hypothesis if it is falling in this region. Likewise, you will have the two-tailed test. Here we assume we want, in the null hypothesis, the claim is that their two variances are same, and in the alternative it is that they are different, right? Considering this test statistic, we know that we are going to reject the null hypothesis if it is falling in this region. So this is basically F star, right? You know that F is skewed, right? So this is your F of 1 minus alpha by 2 and this is F of alpha by 2. So area over here is alpha by 2. Again, area to this side would be alpha by 2, and here we will have 1 minus alpha in between. Okay. So for the upper tail you will have F alpha by 2 degrees, the 2 degrees of freedom will also be there. So if it is falling in this region, or if it is falling in this region, then it would be the test statistic if it is less than 1 minus alpha by 2. Okay. So in this way you can conduct the test for the two variances. So to understand this, let us consider an example. Consider a scenario where a utility provider operates two facilities designated as facility A and B, which process water for distribution. The management wishes to determine whether there is a discrepancy in the consistency of the water's pH levels between the two facilities, which could arise from variations in the equipment used at each site. So the question itself says that you are interested to determine whether there is a discrepancy in the consistency of the water's pH level. So consistency means that we are talking about variability. Less consistency means that more variability. Okay. So to investigate this, samples of water from 10 different containers are collected from each facility, and these are the pH levels that they obtain. You have to determine whether the variances in pH levels at facility A and facility B differ significantly. Okay, the two are different. So it would be your two-tailed test. Okay. The test statistic would be simply you can substitute the sample variances. Because you have the data set, you will calculate your x bar, right? x1 bar and x2 bar you can get, and likewise you can get s1 square and s2 square also, right? So you will substitute it over here. What you get is it is approximately 1.23. So if you look at the critical values also from the table, or you use the software, you can easily get it that this value, because this is what? This is alpha by 2 and this one is 1 minus alpha by 2. So since alpha is 0.05, right? So alpha by 2 would be 0.025 and 1 minus alpha by 2 would be 0.975. And since the total number of observations is 9 in both the cases, so degree of freedom would be n1 minus 1 and n2 minus 1, that is 9 in each case. So you can see that 1 minus 2, this test statistic that you have calculated over here, right, it does not fall in the rejection region, right? Because we want to see, we are going to reject if your test statistic would have been less than 0.2484 or if it was greater than 4.026. So you have, what you have is 1.23, so it is not going to fall in the critical region. So you fail to reject the null hypothesis. It means that from both the facilities, the pH values are all consistent, right? They are coming out as same. Okay. Next, we have the test for the two proportions. Again, we know that in case of two proportions, binomial and your normal approximation would come. So in right tail test, what it will be that the difference of the two proportions is greater than the hypothesized value, right? The test statistic would be this, because P1 hat minus P2 hat minus P naught. P naught is basically under the null hypothesis because it is P1 minus P2 only, but under the null hypothesis P1 minus P2 is P naught under H naught. So that is why we write it, and we know that this in the denominator you have your standard error. So we have seen this test statistic earlier also in week 5. So for level alpha, you reject the null hypothesis if the test statistic that you have obtained is greater than or equal to the critical value. So you have to look at the 8th theorem in week 5. Okay. So if it is like this, so you reject the null hypothesis if it is falling in this portion. Left tail test would come how? Obviously, here it would be, this one would be greater than or equal to P naught, and this side it would be less than P naught because it is a left tail test. The test statistic would remain the same. Rejection region would change because now we would be looking at the lower tail. So you have to check the condition that your test statistic is less than your critical value or not. Alright. So these are easy steps, and most of obviously the results in your proportion, when you are dealing with a single proportion or the difference of the two proportions, it is in sync with what you have obtained for the means, because difference of means. Because in difference of means you have your this one normal distribution, right? So in this case also you will get normal distribution. And obviously when sigma is unknown, then you will have t distribution in case of for means. Otherwise, if it is known, then you would have the normal distribution, standard normal. Likewise, you can have the two-tailed test also. Difference of the two proportions is not same as P naught. That is the specified value. We can take it as 0 also. Test statistic would remain same, and you would reject the null hypothesis if this happens, right? If it is minus z alpha by 2 this side, it would be z alpha by 2 because it is symmetric. Here it would be alpha by 2, and this is again alpha by 2. So in between you have 1 minus alpha. So you will reject the null hypothesis if it falls in this shaded portion. Okay. So all the tests, they are very simple and they follow the same pattern more or less. You have to first of all identify what is the hypothesis in your given problem and what is the scenario, right? If you identify that it is about the proportion, or if it is talking about mean, or if it is even mean, then under what category it is, either is independent or dependent, right? So also those things you have to be careful with. So to understand this, let us consider an example. An epidemiologist is studying the effectiveness of new online health education portal compared to traditional in-person health workshop. So he's comparing the online health education versus your in-person health workshop, that is the traditional method. From a community of 500 individuals, 200 are randomly selected to receive access to the online health education portal, and the remaining 300 individuals participate in regular in-person workshops. Right? After 6 months, all participants complete a health literacy survey, and the results are summarized as follows. So those who pass the survey, it is 160 for online and 210 for in-person, and did not pass is 40 and 90, because there were total 200 in this case and there were 300 in the second one. So you have to determine whether the online health education portal increased the proportion of individuals who passed the literacy survey. Okay, because here if you see in online portal you have 160 and it is 210 although, but here in this case not passing is 40 only, and in this case you have 90, right? So you have to see whether the proportion for online health education increases is more than that from the traditional ones. So if you denote P1 as the proportion of individuals who pass the health literacy survey using the online portal and the others use the in-person workshops, then you have the alternative as that proportion from online is more than that of the traditional one. So P1 greater than P2. You can calculate P1 hat and P2 hat, because P1 hat would be 160 because those who passed, and 200 is those who participated in the first one, in the online one, and P2 is 210 by 300. So you can see the proportion P1 hat is coming out more as P2 hat, and when we further analyze it, you can find the test statistic. You will substitute the values of P1 hat and P2 hat, N1 and N2, what you get is approximately 2.58. Since your test statistic value, that is 2.58, is greater than your critical value, that is 1.645, you reject the null hypothesis and conclude that the online health education portal increases the proportion of individuals who pass the health literacy rate. So P1 is actually greater than P2. Okay. So obviously the conclusion that you draw at the end is equally important, because that is what you are going to interpret. First you have to analyze and then you have to report these results in the form of these statements that based upon the question or the problem that you are dealing with, you have to conclude in the form of the statements that what is happening over here. So we have looked at different tests. In case of the two sample problems, we have looked at difference of means, then we have looked at the ratio of the variances, and then we have finally talked about the difference of the two proportions.